Hey guys, Mr. Stevens here with a lesson on applying algebra. Now that we've learnt a few different techniques and different tools that we can use when we're working with algebra, we're going to have a go at applying some of them to practical situations. Here is an example where we're told that we can work out the perimeter of a rectangle by adding up 2 times the length plus 2 times the breadth. And that makes sense to us because if we wanted to find the perimeter of this rectangle, we would need to go L plus B plus L plus B. We would need to add up the length of all sides. And we're given what L and B equal, and we're asked to calculate the perimeter. So what we have here is a substitution question. We're told what L equals, and we're told what B equals, and we need to take the numbers and replace the letters with them, which is exactly what we would do in a substitution question. But you can see the question is sort of hidden in the practical scenario of calculating the perimeter of this rectangle. So let's go ahead and solve the question. We're going to replace our L with a 5, and we're going to replace our B with a 7. And we're just going to work this out. 2 times 5 is 10, plus 2 times 7 is 14. So the perimeter of this rectangle is 24. And in this case, in part A, we're not told what the units are, so I'm just going to write units. Now let's have a look at part B. Again, we're using the same formula, 2L plus 2B. But this time we're given different values. L equals 8 and B equals 3. So I'm going to replace L with 8 and I'm going to replace B with 3. And now we're going to work this out. 2 times 8 is 16, plus 2 times 3 is 6. So the answer here is 22 centimeters. We're told that it's in centimeters this time. So yeah, once again, this is just a substitution question, but instead of being given just a formula and being told x equals 4, the question is given to us almost in disguise as solving a practical problem. But we're still applying the exact same things we learnt back when we did substitution a couple weeks ago. Let's look at another example here. What we're looking at here is we're given a problem in words, and we're going to try and write it down in maths. Okay, let's look at this first one. We're trying to find the total cost of 10 bottles when each bottle costs X dollars. So what we could do is we could add up 10 lots of X, but that's going to take a long time. What's another way we can think of that we can write 10 lots of X much more simply than that? We can write 10 times X, or 10X. Second example. Again, we're looking for the total cost in dollars of hiring a plumber for N hours, where the plumber charges a $30 call-out fee plus $60 an hour. So we're always going to be charged the $30, so that will always be part of the cost. And then we're going to add onto our cost $60 for every n hours. So we need 60 lots of n. Same as we had in the first question. Let's look at the last example, where again, trying to come up with an expression for cost. This time the call out fee is $60 and the per hour rate is 50. And we've been asked to calculate the cost for an 8-hour job. So when n equals 8, cost equals 60 plus 50 times 8. So 50 times 8, you can either do that on your calculator, or you can recognize that you can do 8 times 5 equals 40, and 40 times 10 equals 400. Therefore, the total cost is $460 to hire this plumber for 8 hours. Okay, now you guys are going to go to page 369 and you're going to do the 6 questions there where you'll see various examples of either this kind of problem, coming up with an algebraic expression given a problem in words, or something like this. It might be a substitution, it might be an expanding brackets question, it might be a collecting like terms question, but it will be disguised in a practical scenario. Feel free to ask your teacher for some help if you're not quite sure of what the question is asking for you, and we'll all be happy to help you out. Thanks, guys.